Hello students. So in the previous video we took some examples on DTFT. Now in this video I'll be taking some examples which requires the use of properties of DTFT. That means to get the end solution of this we have to use the properties of DTFT. So the properties will reduces the number of steps required to get the end solution. So that is the advantage of that. Now how to apply the properties? So for that we need to make some small modifications in the given signal. Now what are the modifications, how to deal with this? So that is what we are going to discuss in this video. Okay, so in the first one I'm taking this problem. So it is given a time domain signal has to be found given its frequency domain value x of e power j omega is equal to cos square omega. Now this signal we have to apply the property. So it is not, I am not written the problem completely. So they will be particularly mentioned that like they will add up using properties or using appropriate property of DTFT. So some problems require one property, some problems some problem require more than one property or two or three properties to apply to get the end result. So applying the property will reduces the number of steps as well, and we will get the end result soon. Okay, so let's solving this. So let's start solving this problem. So we have x of n is equal to 1 by 2 pi integral of x of e power j omega e power j omega n d omega. Now this, substitute this value x of, that is cos square omega e power j omega n d omega. Now this cos square omega can be written as cos omega square. So based on that I am going to convert this cos into exponential. So that is e power j omega plus e power minus j omega divided by 2 whole square e power j omega n d omega. Next, if you take this 2 outside, so that will become 2 square, that makes 4. 4 into 2 is 8 pi minus pi to plus pi. So we'll leave with, if you multiply this, e power j 2 omega e power j omega n d omega. Or you can do one more thing. If you take this outside, you will leave with a plus b whole square. So that is, if you elaborate this, so it is a square plus b square plus 2 ab, that is 2 j omega e power minus j omega. So all these things under 1 into e power j omega n d omega. Now these two terms, e power j omega minus j omega, that becomes 1. So left with 8 pi minus pi. In this step we will leave with e power j 2 omega plus e power minus j 2 omega plus 2 into e power j omega n d omega. Okay, so if you multiply this, 1 by 8 pi e power j 2 omega e power j omega n d omega plus 1 by 8 pi. Okay, I won't be writing this here since this is applicable for whole signal. I'll write here itself. Yes, integral of e power minus j to omega e power j omega n d omega plus 2 e power j omega n d omega. Okay. So just for my convenience, I am going to rewrite the same expression in this form. Why, I will tell you later. I'll take 1 by 4 and I'll keep this. I'm writing this 1 by 2 pi integral of minus pi to plus pi e power j 2 omega e power j omega n d omega plus integral of minus pi to plus pi e power minus j 2 omega e power j omega d omega. So next step, if we go further, minus pi to plus pi e power 2 into e power j omega n d omega. Now why I have written this? So we are trying to find out x of n. So the expression x of n is 1 by 2 pi minus pi to plus pi x of e power j omega into e power j omega n d omega. Now if you have a look at this, here in place of x of e power j omega we have three different terms. Here we have e power j2 omega, here we have e power minus j2 omega, and here we have 2. So apart from this, everything is same. So that means, taking this 1 by 4 apart, if you compare these two expression, this one and this one, you can see x of e power j omega is having three different values, but we didn't get that easily. How means, so if you observe, if you perform dtft on delta n, you will get 1. So I think in the last video I might have said something like e power j omega n. If that thing, please make that correction. So this is the time shifted version you are going to get. That is delta n minus n naught. If you perform this thing, delta n minus n naught, then you will get e power j omega n naught. Okay, e power minus j omega n naught. So this is the dtft of delta n minus n naught. So now if you observe this, to get this one we have to apply the time shifting property here. Now observe from the comparison of these two, this is just for your understanding purpose I am writing these things. Okay, so after this, if you observe, x of e power j omega in the first part is e power j 2 omega. Now if you see this one, we have similar term, but here in place of n naught we have minus 2. So that means, to get that, if you go back reverse, so we have to perform the dtft of this signal n plus 2. If delta n plus 2 is performed dtft, then you will get e power j2 omega, which is our x of e power j omega in the first case, if you observe this. Okay, now in the second one, this x of e power j omega is equal to e power minus j 2 omega. So this, to get this, we have to perform dtft for, just observe the signal, in place of n naught we have 2, that means delta n minus 2. Okay, now in the third one, this x of e power j omega is, its value is 2. Now to get this, observe this, if delta n is performed dtft, you will get 1. Now if you want to get 2, so you have to go for 2 into delta n. If 2 into delta n is performed transformation, you will get this. That means I am just showing the reverse process of that. So delta n minus n naught will give you e power minus j omega n naught. Delta n will give us 1, or if you take the time shifting property, delta n minus n naught is e power minus omega n naught into x of e power j omega. There e power j omega is what? This e power j omega is the dtft of this signal, that is 1. So that will give you e power minus j omega n naught into 1. If you are wondering how the value is e power minus j omega n naught, so this is the reason we are going to get it like this. E power minus j omega n naught into 1. So that means we are applying time shifting property. So the same time shifting property has been applied here in this case. Now if delta n plus 2 is performed dtft, so this is the time shifting version of delta n. So that means e power j2 omega into 1, that is what you are going to get, e power j2 omega into 1. That 1 is not mentioned there, so that is the reason. X, this e power j2 omega into 1, this value x of e power j omega is e power j2 omega into 1. So this is nothing but we got it as a time shifted version. So that's why based on this you can write that applying time shifting property. Now how we have applied, I have written here. Now if you observe this, this part 1 by 4 kept aside, so I have brought the equation so that it will look similar to this synthesis equation form, so that will be easier for us to compare. So based on that we got what is our x of e power j omega. Now applying time shifting property, we can write x of n is equal to 1 by 4 delta n plus 2 plus delta n minus 2 plus 2 delta n. So there is no need to go for integrating, applying the limit and then simplifying. So using time shifting property we can write it like this. Okay. So this is one kind of approach here. Now this is in case of delta, if you are dealing with delta n and all, you can go for this. The similar way, I want to take one more example here. So the problem is given like this: using appropriate properties, find dtft of the following signal. So the signal is given as x of n is equal to 1 by 2 n u of n minus 2. Before going to this problem, I just want to mention one more thing. If the same problem is given, even though if it is not mentioned using property of dtft, it is okay. You can use the property and you have to mention which property you have applied. Like this time shifting property I have applied. So based on that, we got the end result like this. Okay, but in some problems as this one, so they have particularly mentioned using appropriate properties find the dtft of the following signal. Now you have to use the properties only to get the solution for this one. Okay, now so what is given is x of n is equal to 1 by 2 n u of n minus 2. Now if you observe, we have n and we have n minus 2, but if you slightly more change this one, we can apply the time shifting property. That means if the time shifting property is applied, so it will be for the entire signal. N minus n naught is applied for an entire x of n. So to make that as happen, I will slightly modify this as 1 by 2 square 1 by 2 n minus 2. So here plus 2 minus 2 will get cancelled and we will remain with 1 by 2 to the power of n only. So that means it doesn't affect our signal x of n. Okay, or you can write in rewriting or mention something like this can be also written as like that. You can use some words. Now if you observe here, in the very beginning, that is the very first problem, we solved something like alpha n into u of n performing dtft will end up with 1 by 1 minus alpha e to the power of minus j omega. So this is what we got. This is some standard derivatives for of dtft. Now in place of 1 by 2, what if I replace, sorry, in place of alpha, if I replace 1 by 2, then I will get the expression in this way: 1 minus 1 by 2, yes, 1 by 2 e to the power of minus j omega. Okay, now if I go with this one, 1 by 2 n minus 2 u of n minus 2. So you have to remember one thing, this term, what we having this term here, this term is the dtft of that is, this is called x of e power j omega. If you apply 1 by 2 into u of n. Now if you apply this, so this is the time shifting property. So according to this, it says time shifting property e power minus j omega n naught into x of e power j omega. Now what is this x of e power j omega? This is nothing but the value of the signal when it is not time shifted. Okay, so when without performing time shifting, whatever you get the dtft of the signal, that is the x of e power j omega, you have to write here in this part. So that is the meaning of that. That means if you 1 by 2 n minus 2 u of n minus 2 is performed dtft, now using time shifting property, this one we can write the expression. So how? So let's say this. So for that you have to remember the time shifting property, that is important. So using time shifting property, 1 by 2 n minus 2 u of n minus 2. So this should give us e power minus j omega n naught into x of e power j omega. So that is the time shifting property. Now I'm going to write the same here. So e power minus j, in place of n naught we have minus 2, sorry, not minus 2, plus 2, right? So e power minus j 2 omega. So I can write omega 2, I am writing 2 omega. Now this x of e power j omega, where it is, this is the 1 divided by 1 minus 1 by 2 e power minus j omega. So this is what we have to write here. So this is the first part. Now after applying time shifting property, so this what you are going to get. So this entire term, now this entire term is my x of e power j omega. Why I am writing this? Because I have to apply one more property to get the end result. As you can see, so I have taken this part of the signal and I have applied time shifting property. Now still we have one more thing left here, and how to get there? We have linearity property. So it says a x of n plus b y of n. So if you apply this term, you should get a x of e power j omega plus b y of e power j omega. Just for remembrance, I am writing this. So now in place of a x of n, so observe this, this is my x of n signal. Now this term is also x of n. This 1 by 2 to the power of 4 is a constant value. So that means here 1 by 4 into 1 by 2 n minus 2 u of n minus 2. So all these things belong to x of n only. So now we have taken one at a time. So this part 1 by 2 n minus 2 of n minus 2. So we have got the value for this if you perform DTFT here in this one using time shifting property. So if you apply DTFT for that, you will get e power minus j2 omega 1 divided by 1 minus 1 by 2 e power minus j omega. So this is my x of e power j omega now for that value of x of n. Now if you take entire x of n, this is similar to applying 1 by 4 into x of e power j omega, and since there is no y term, it will be left 0. So that means 1 by 4 into where is this x of e power j omega? This term I have to substitute that e power minus j 2 omega into 1 divided by 1 minus 1 by 2 e power j omega. Okay, e power minus j omega. Now if you want, you can go further step by taking the LCM for this term. You can end it here itself, or you can go further e power minus j to omega. So you will get e power minus, sorry, plus, not minus, e power j omega minus 1 by 2 to the power of e power j omega. So this will be the final answer for the signal. So that means we have computed x of e power j omega using the property. Okay. So this is the end result. We can stop here or here. So this is how we will get to the end solution of this using the properties. Okay. In the same way, I'll take one more example. So the problem given is using appropriate property, same thing, find the DTFT of signal. So given signal x of n is sine pi by 4 n 1 by 4 n u of n minus 1. So this is the problem given here. Now you have to think, you have a n minus 1 means obviously you can apply time shifting property, but all n should match to the same thing. Let's see what changes we can do here. So first thing is we have 1 by 4 n. So as we did in the previous case, we can alter that. Okay, that means we can rewrite 1 by 4 n u of n minus 1. Coming to the sine term, just convert this sine term into exponential form. So e sine pi by 4 n is there, so that gives us e power j pi by 4 n minus e power minus j pi by 4 n divided by 2j. So this is the form, and 1 by 4, see if you apply n minus 1 is there, so the power will be 1, and 1 by 4 n minus 1 u of n minus 1. So this is the signal here, u of n minus 1. So this, after this, let's see further simplification we can do. We have 1 by 4 and this 2j. I can take this out, that gives 1 by 8j, and this term is e power j pi by 4 n minus e power minus j pi by 4 n into 1 by 4 n minus 1 u of n minus 1. Okay. In the next step, let's multiply this. So 1 by 8j e power j pi by 4 n into 1 by 4 n minus 1 u of n minus 1 minus e power minus j pi by 4 n 1 by 4 n minus 1 u of n minus 1. Okay, so this is the simplest version of this. Let's see. These two looks similar. The only difference is we have plus j, we have minus j here. Now, if we get the result for plus j, we can write the same by just modifying simple changes in that one. If you observe 1 by 4 n minus 1 is there, u of n minus 1 is there. So, as in the previous case, let's take the signal from here. 1 by 4 u of n, if you apply dt ft for this signal, then you will get 1 divided by 1 minus 1 by 4 e power minus j omega. Now this you can simplify or you can keep it as it is. If you apply time shifting for this 1 by 4 n minus 1 u of n minus 1. So I am writing this using time shift property. So that is e power minus j omega n naught is there. So what is the value of n naught here? You can say this is 1. So that means I left it as it is, e power minus j omega into x of e power j omega. As I mentioned, this is what my x of e power j omega, which I have to substitute here. So e power minus j omega into 1 divided by 1 minus 1 by 4 e power minus j omega. Now you can simplify this. E power take the so e power j omega minus 1 by 4, and in the numerator you will get 1. Now if you take this to now this term is e power minus j omega, this one is plus j omega. So this term will become 1 here. So we'll end up with 1 divided by e power j omega minus 1 by 4. Now you have to decide whether we have to go for simplification or not by looking at the property that you are going to apply. So we are in the first phase. One more property is there that we have to apply. So that's why I am trying to reduce as much as possible. Now this value 1 divided by e power j omega minus 1 by 4 is my x of e power j omega right now. Observe the signal. I have e power j pi by 4 n, which remembers we can use something like this, that is e power j beta n into x of n. If you perform DTFT for this signal, then you will get x of e power j omega minus beta. That is, it's a property called frequency shift property. Now, if you observe this, we have x of n e power j beta n. So this entire signal is considered x of n. So next we live with e power j pi by 4n. In place of beta we have pi by 4. Now based on this assumption, we can write it like this using frequency shift property: e power j pi by 4n into 1 by 4 n minus 1 u of n minus 1. So this can be written as You observe this, it is x of e power j omega minus beta. That means whatever you have x of e power j omega, there you have to perform the time shift where the shifting factor is beta. Here in place of beta we have pi by 4. So x of e power j omega minus pi by 4. Now for 1 by 4 n minus 1 u of n minus 1, this is what we ended as a x of e power j omega. Now in this term, omega should be replaced by omega minus pi by 4. So that gives us 1 divided by e to the power of j omega minus pi by 4 minus 1 by 4. So this is frequency shift property. Now this term what we have here, this is my latest value of x of e power j omega. Why I have to apply one more property left. So this part of the signal is dealt with. Now 1 by 8 j is there. If you multiply that, so this is just a simple scaling factor. So you can use linearity property. You can mention that if you want to. So there is no other term. So this term y term is not there. So that is left 0. So now 1 by 8j. So this is the scale factor. Now what is our x of n? You go to this place. This is x of n now. E power j pi by 4 n u of 1 by 4 n minus 1 u of n minus 1. So this term is 1 by 8j into x of e power j omega. So that means 1 by 8j should be multiplied with x of e power j omega, which is this value, into 1 divided by e power j omega minus pi by 4 minus 1 by 4. Now if you observe this, 1 by 8j e power j pi by 4n into 1 by 4n minus 1 u of n minus 1. So this entire term has x of e power j omega as 1 by 8j, 1 by e power j omega minus pi by 4 minus 1 by 4. In the same way, if you go to the next part of the signal, that is this term. So these two are alike. Say 1 by 8j is multiplied to this term as well, but the only difference is in place of j we have minus j. That means we have to slightly modify this one. So how means? So similarly, for 1 by 8j e power minus j pi by 4n into 1 by 4 to the power of n minus 1 u of n minus 1. So for this term, you can write it like this: 1 by 8j, same using all those properties. So you have minus plus j, you have minus j minus pi by 4. So that means e power j omega plus pi by 4 plus pi by 4 minus 1 by 4. Now this term, and better should give a name here for this one. So based on this we can write, therefore x of e power j omega after this 1 by 8j into 1 divided by e power j omega minus pi by 4 minus 1 by 4. minus 1 divided by e power j omega plus pi by 4 minus 1 by 4. So this is the final answer. So hope you have understood this method of applying the properties to get the end result. Now I want you to try some problems on your own to get the result here. Look at the properties that you can apply for to get the end result here. Okay. So using properties only you have to solve this, and that will be better. Okay. And I'll give try this one, and we also have one more kind of problem here. This looks simple, but try to get the answer. So again cos omega plus j sin omega. So you can use the property to get the end result of this one. Okay. Yes. In the next video, I'll take some problems on inverse DTFT as well, and try to these two problems on your own to get the end result. Okay. I hope you have understood the method that I used to solve this problem. So if you have any queries, do reply or comment in this video. So thank you for your time.